Now I'm going to do the same thing but backwards in time, because like I said earlier, the addition of one dimension allows us to see what happens both forwards in time and backwards in time uniquely. We can invert the dynamics either way. And so I'm going to do the same example, but think about what would the previous square have looked like if this is the square we're looking at now. And I'm going to do it twice again, and you'll see that once again we have tent map dynamics, symbolic dynamics, but backwards in time. Instead of being able to label what happens to these points vertically, we're going to be able to do it horizontally. And this two-dimensional lattice will allow us to pick any point in the symbol plane and uniquely specify its forward time dynamics and its backward time dynamics. So we start with A and B, and now we just want to run the Danish pastry dynamics in reverse. So instead of stretch, squash, cut, and fold, we're going to cut and unfold, and then stretch and squash in the opposite directions. We had cut here and moved what was there under, and so we want to undo that, which means we're going to have to cut at the halfway point and rotate it back like that. And now this thing is half too short in this direction and twice too long in that direction, so I will squash along the horizontal direction and stretch along the vertical, completely undoing what we had done before. Okay? And so now you see that instead of getting a horizontal stratification, we're getting a vertical stratification. So let me do it again, just so that becomes a little more lucid. So now we have the same idea, except we will look at the horizontal strips and see where they ended up in the vertical plane after one reverse iteration and after two reverse iterations. And the reverse is important because I'm going to write the symbol sequences backwards, since each one represents another step backwards in time. And you'll see that if you read it backwards, you get the same symbolic dynamics as the tent map. After one iteration, we saw that everything in the top half ended up on the left side, right? Because we cut off the bottom half and moved it over to the right. So everything on the top first symbol backwards in time is 0, and everything on the bottom's first symbol backwards in time is 1. Here, the decimal point is on the right, and the numbers are going to go this way because we're going backwards in time. Now I look at what happens after second iteration. On the top of the top piece, after the second iteration, well, we just cut on the bottom and move everything else over here. And when we squash it in the end, this guy looks like this. So he's still on the left side. So the second symbol backwards in time for the top strip is 0. Bottom of the top strip, we know its first symbol was 0, and it ended up here. But then it gets cut because we cut this way, and the and it gets moved over here. So in the end, it's over here in the 1 segment. So its symbol is 1, going backwards in time. And now we look at the top of the bottom first half. We know its first symbol is 1. And so this guy ended up down here because I cut and I rotated this strip so it ended up on the bottom. So this should have been right there. So it becomes 1, 1. The last one is 1, 0. It looks kind of different from the tent map if you're reading left to right, but the proper way to read this is right to left because it's going backwards in time. And if you do that, same as the tent map. And the reason is it's the same transformation as the tent map. Stretching, folding, and or stretching by factors of 2 and folding. This is the dynamics of the Danish pastry, and so the punchline is if you look at the square at some arbitrary point in time, you know that you can sub-partition it horizontally going backwards in time, and you can make this partition as fine as you want because you can just keep iterating this. You know how to do it for the tent map. And you can do it forwards in time vertically. So any point here corresponds to a unique backward in time and forward in time trajectory. So it is a unique point in the state space of the Danish pastry. And as I do this finer and finer, then I get this grid of points here. And each one I can use this to assign the symbolic dynamics, and then I can use the key from going from the set of symbols to a number in the plane from the tent map to convert to a number. And I can figure out what every state space point does qualitatively.